Find the volume of the solid obtained by rotating the region bounded by y equals sine squared of x times cosine squared of x and y equals 0. For x is between 0 and pi over 2 about the x-axis. So the graph is provided for us. We're rotating about the x-axis, and we recognize that the region is flush up against the axis, so we should try to draw a rectangle that's perpendicular to the axis and go for disk method. There's no gap between the region and the axis. It's going to be an x because it's an upright rectangle that will be moved from left to right. And so what we need then is just what the radius is. In the disk method, the radius is just the distance, how long the rectangle is, and here it's the height of the function. It is sine squared times x cosine squared times cosine squared. The a and the b are 0 and pi over 2. So to get the volume, we must then square sine squared cosine squared. Alright, well, in doing that, we're going to call it sine fourth cosine fourth. And whenever you have no odd powers present with sine and cosine, then you just use the half angle identities to decompose the even powers down to a point where you can integrate. So sine squared is 1/2 the quantity of 1 minus the cosine of twice x. Cosine squared on x is 1/2 the quantity of 1 plus the cosine on twice x. What we're going to do though is call these sine squared squared, cosine squared squared, and replace these guys, but we still have to square to take it to the fourth power. Okay. Let's go to the next slide because we need to be careful how we do this. There's a long way and a short way. We want to figure out the best way possible to set up this integration. And so, if we just square the 1/2 and square the quantity here, that should be so if we square the half, we get a fourth. We square this half, we get a fourth. Those two fourths come out as a 16th. Now both of these guys, 1 minus the cosine of twice x and 1 plus the cosine of twice x, both of those guys get squared. But hopefully you recognize it as 1 minus something and 1 plus the same thing. It is the difference of squares. If we multiply it out first, we're going to end up just with a binomial, and that'll be easier to square. If we have 1 minus cosine twice x and 1 plus cosine twice x, when we FOIL it out, the two middle terms are canceled out. And we'll end up with 1 minus the cosine squared on twice x. And then don't forget though, we definitely have to square that. And it's just easy to deal with the binomial instead of the trinomial, the two trinomials that would have came out if we would have squared them individually. So squaring out this binomial, we'll get 1 minus 2 of them plus cosine to the fourth on twice x. And we pull the 16 out, so now we have pi over 16. But here we are with more powers of cosine, even powers. So these guys have to be decomposed using the same half angle identity. Replace cosine squared on twice x with 1/2 the quantity of 1 plus the cosine on 4x. The angle must be double. But then here we are to the fourth power, so we'll treat it as cosine squared on twice x, then squared. And then later we'll square it. Now watch what happens here with the 2 that was there from squaring that out. The 1/2 from the half angle identity, the 2 and the half cancel each other, and we still have that quantity 1 plus the cosine of 4x. Over here, when we square the half, we get a fourth, and if we FOIL out 1 plus cosine 4x times itself, squaring that guy, we get 1 plus 2 of them, and then we get cosine squared. We're getting someplace. It's just taking a long time to get there, but if we're careful with the algebra, we're going to find out that it's not going to be that bad in the end. And so that guy squared is here. Now, the one last thing we need to worry about is this final cosine squared on 4x. But let's distribute. Let's see where we're at right now. We have 1 minus 1. Hey, those guys are going to cancel out. Minus the cosine on 4x. Distribute out here. We'll have a fourth plus a half of the cosine on 4x plus a fourth of cosine squared. So that's where we're at right now. And if you're looking at minus the cosine of 4x and half the cosine of 4x, no reason to stop you from putting those together. And that'll be put together as minus 1/2 the cosine on 4x. We have this 1/4, and we have this 1/4, and now we decompose cosine squared on 4x with 1/2, 1 plus the cosine on 8x, double the angle. And now let's distribute. So we're talking about a fourth minus a half cosine 4x plus an eighth plus a fourth. Oh, that should be an eighth, I'm sorry. Plus an eighth of the cosine on 8x. What's going to happen with these guys? The cosine on 4x and the cosine on 8x. Let's take a good close look at those guys. What is the period of cosine on 4x? You take the old period of cosine x and divide it by that number that's multiplied by x. 4 in this case. 2 pi over 4 is pi over 2. This guy has a period of pi over 2, and we're integrating from 0 to pi over 2. We are integrating a full period of this function. And so if that's the case, then this positive area will cancel with this negative area. That integral is bound to be 0. How about cosine 8x? What's the period of that? You take the 2 pi, which is the old period, and you divide by this time 8. And that's going to be pi over 4. So we're integrating from 0 to pi over 2. We're getting 2 full periods of the cosine on 8x, where these positive areas, the full one and these two half ones, cancel with these two full ones. Total area is 0. So that's great, because then we don't have to worry about those two parts to our integral, and we can just focus on putting the 1/4 and the 1/8 together. Those two guys will go out. 1/4 and 1/8 give you 3/8. You can even take that 3/8 out, 3 pi over 16 times 8, and then integrate 1 and get x from 0 to pi over 2. So we just get pi over 2. And then last step would be, well, I'm looking at 16 and another 16. 16 squared is 256. And so we'll have 3 pi squared over 256 is our final answer. Okay, be on the lookout for these guys to help you out. You don't always have to integrate if you recognize that you're integrating either a full period or multiple periods